Hello, ladies and gentlemen. We're going to talk about solubility. Chapter 3 is all about solubility. This is sort of our first official lesson on it. We're going to try to figure out why some things are soluble and why things are not. And some things can dissolve a lot. They have high solubility. And some things do not dissolve at all. They have low solubility. So in the real world, we say there are two words. Things are either soluble or insoluble. But in theory, nothing is really insoluble. Everything will dissolve to some extent in water. It may take 50 or 100 years, but everything will dissolve to some extent. So we have a better word than insoluble. And the one that we're going to focus on the majority of the time is the words low solubility. So these do not dissolve much at all. In fact, it's less than 0.1 molar for its concentration. And there is a table in our data booklet that gives us all the combinations of compounds that have low solubility or are soluble. So if you take out your data booklet, this is the chart right here. This is what it looks like. It's called the solubility of common compounds in water. Super fancy, but it's really straightforward, and I want to spend about a minute just going over some of these characteristics, and I'll show you how easy it is to use. First off, you're going to see the first three rows up here say all. This whole first column is the negative ions. Those are all the anions. They're all the things that are negative on the periodic table, and your polyatomic ions that are negative. Every single negative ion will be soluble if it's mixed with those. Every negative ion will be soluble if it's mixed with H+. And every negative ion will be soluble if it's mixed with NH4+. So these things are soluble, will dissolve 100%. Okay? Then you get down to these rows down here, and we have combinations of stuff. Well, Cl, Br, and I, with these three, have low solubility. So these will be a solid in solution. Very little of these ions will dissociate, will dissolve. AgCl, Pb, Br2, Cui, those compounds will stay a solid. Everything else that's up here will be soluble. Okay? And each row is broken up like that. So in the question in your notes here, if you want to flip back, it says determine whether FeCO3 solid is soluble. Well, you just find FeCO3. I start with the negative ion. There's CO3. Fe is down here because Fe is not an alkali. Fe obviously is not H, and Fe is obviously not NH4. So FeCO3 is low solubility. So the question is simply, will FeCO3 dissolve? Is it soluble? The answer is no. It's not soluble. Therefore, it will have low solubility. It's just that simple. That's how you use the chart. So to give you kind of a real-world example, if you mix these ions together, are you going to form chunky solids, or is everything going to stay an ion? Will a precipitate form? Well, you have to do a double replacement. Switch the Na and the Ca, so you're going to get Ca react with SO4 and Na with S. And if you use your chart, and I'll go back to my chart, NaS, Na is right here, S is part of all others. It's soluble. If you want to start with S is right here, Na is an alkali, it's soluble. So Na2S will be soluble. If you want to look for CaSO4, there's the SO4, there's the Ca. It has low solubility. So what that means is when you mix those things in solution, Na2S will be soluble, so it won't even form. It'll just stay in ions floating around in solution. And CaSO4 will be chunky. We don't use the term insoluble. So you will form a precipitate. Chunky solid CaSO4 will be formed when you mix those things together. And a special note, I will burn a few of you on this test and quiz coming up. You have to pay attention to the charges. Cu plus 2 is not the same thing as Cu plus 1. So when you see that row with Cu plus 1 in it, right here, let me change my color, right here, Cu plus 2 is up there. Okay, so Cu plus 1 will be a solid or low solubility with those three things, and Cu plus 2 will be soluble with it. Okay, and that's kind of the end of section 3.3. So what do we do with all this? Well, we write things out showing if they're going to form a solid or not. This will just take 2 minutes and we'll be done. We started this in chapter 1 to give you a quick intro into it. Here it is again. Here are our two formulas. We are going to double replace them and we're going to write out the formula equation. It's going to be fully balanced and it's going to have all the formulas and all of the states. So NaNO3 is going to form, and AgCrO4. Ag2CrO4 because CrO4 is a charge of -2. Make sure it's all balanced. We're going to need a 2 in front of here, 2Na, 2Na, and 2 in front of there. Looks like everything is all peachy. Now we need to fill in the states. Well, we got to use our chart. Look up NaNO3 and look up Ag2CrO4. Take my word for it, this will be aqueous and this will be a solid. Which means when I mix these two things in solution, I will have chunky silver chromate form. You can also write that in complete ionic equation, which is rare. I'm not going to ask you to do that often. Remember, complete ionic form is when you break down all of the all of the aqueous items into its ion form. So AgNO3 will turn into 2Ag, and that's a plus, and 2NO3, that's a minus, 2Na plus, CrO4 minus 2 goes to 2Na plus and 2NO3. Again, I'm breaking that thing down, and solids stay a solid. So it's plus Ag2CrO4 solid. This is the complete ionic form. All of these things are aqueous. I'm just lazy and I'm not writing them in, and that thing is a solid. And lastly, to end this section, what's the net ionic equation? The net ionic equation is simply the ions that form the solid. Eliminate the spectators. If it's the same on either side, that's the spectator. That's gone, that's gone, that's gone, that's gone. So what do we have left? We have 2Ag plus, aqueous, CrO4 minus 2, aqueous. It's going to form Ag2CrO4 solid. So the formula, the complete, and the net ionic equation. We will expand the idea of forming solids and precipitates in solution next class. This is just an intro to what we're really doing. This chapter really starts section 3.5, 3.6, and 3.7. Tomorrow.